Hello everyone, we are discussing circular motion. Now write down conical pendulum. What is a conical pendulum? Look at this. In the previous lectures, we were discussing circular motion in horizontal plane with the help of a rope. And how did you maintain this circular motion? We had an object, a rope, and then the object used to move in a horizontal circle. Throughout, rope was held horizontally like this. An object was moving in the horizontal plane. Some support was present जिसकी वजह से ऑब्जेक्ट नीचे नहीं गिरता था. This is something we have already done. But to make this type of horizontal motion possible, you need to have some support on which this object can move. But now look at this. If you hold an object with the help of a rope like this, then everybody knows that this is simple pendulum, which is called vertical circular motion. And right now we are not interested in this thing. We are interested in this type of motion. And I hope you can see that a cone is getting formed. This is moving and the rope is forming a cone. But there is no horizontal support needed for this type of circular motion of this object. And look at the circular motion. Circular motion is still in what? Horizontal plane. This is the horizontal plane. So, for this type of circular motion, we have a special name which is conical pendulum. So remember, this conical pendulum is nothing but an example of circular motion in horizontal plane without any need of horizontal support. Write down the statement first. Conical pendulum is an example of circular motion in horizontal plane conical pendulum is an example of circular motion in horizontal plane without the need of horizontal support. Without the need of horizontal support. Now, let's understand the whole thing with the help of this setup. This is a rigid support. An object is moving in a cone like this. This is the path it is going to follow. That's your object its mass is m, length of the rope is L, but radius of the circle is R, shown with the help of this blue line. This radius is what? Is R. I hope everybody can see this. Length of rope is L, length of radius of the circle is what? R. Now, let me ask you a simple question first. What do you think will remain same for a given conical pendulum as I rotate? What is that which remains same? L, length of the rope, or radius of the rope? Or they both are same? Or they both will change as I change the rotational speed? What do you think which will remain same? Length of the rope, radius of the circle, both, none? Whatever you think, write down this in the comment box, and at the same time I'm giving you this conical setup. That's what the question is. If I change rotational speed, I hope you can see, as I increase, it goes up, and as I decrease the omega, it comes down. All the while, length remains same, but the radius, it keeps on changing. As I increase angular velocity, it moves in a larger radius circle. As I decrease omega, radius of the circle, it decreases. So for the given setup, remember that L will remain same, but R is something which can change. Or you can say that R is something which depends upon angular velocity omega. Write down like this. Now, what is happening at a given moment? Downward force of mg is acting on the object. This is a rope, and in the rope you will find always what? Tension force. और टेंशन कहाँ लगती है? आपको पता है that tension force always acts away from the body. This is T. Tension is a pulling force. It acts away from the body. So this is the rope, and it's pulling on this object. This pull, I hope you can see, that's the tension force. Downward is what? mg. Under these two forces, this object is performing this horizontal circular motion. Now suppose this object is moving with speed v or angular velocity omega. We'll find the answer in terms of v, and then we'll develop the whole thing in terms of omega also. The object is moving with v, and for this particular question we are keeping our v same. If we keep v same, it is what? uniform circular motion. Speed will be kept what? Same. But the moment I say speed will be kept same, this R, I hope you can see, is not going to change. ये R कब change होता है? जब आप speed को कम या ज़्यादा करते हो. We are interested in uniform circular motion, and therefore we'll keep the V part what? Same. Put down this and then write down the statement. In the given figure, object is moving with constant speed V. Object is moving with constant speed V. Inside the bracket UCM, uniform circular motion. Or we can say that its angular velocity is constant. Or we can say that its angular velocity is constant. Now pay attention to the statement. I said speed, I didn't say velocity. And I said angular velocity. What is angular velocity? That's how you will get the angular velocity. Sense of rotation. Direction of V is continuously changing. So velocity is not same, but direction of angular velocity is throughout same. Its magnitude is also same, and therefore we should write what? Constant speed. We cannot write what? Constant velocity. We can write what? Constant angular velocity. Now, if you have all these forces, T and mg, and semi-cone angle is theta. I hope you can see the vertical broken line. This is the half angle of the cone, which is theta. We need a relationship between T, mg, theta, L, and all these things. Now, how do we obtain these relations? For that part, look here. I will draw the same three body diagram right here at this point. So this is your object. Downward force is mg. This is the tension force T. Now my question is what? Which force should be resolved into its components? T or mg? This is something which is coming from laws of motion. What do you think? किसको रिजॉल्व करना चाहिए उसके कंपोनेंट्स में, T को या फिर mg को? And try to think of the logic which I gave you, which decides which one should be resolved in its components. Good. Most of you are saying T. That is correct. If you resolve mg, even then you will get the correct answer. But how do you prefer to resolve? Comes from this argument. We take one of the axes in the direction of known acceleration. जिस तरफ acceleration का knowledge हो, एक एक्सेस आप वहां लेते हैं और आपको इस फिगर में एक्सेलरेशन का डायरेक्शन पता है. What is this point? This point is the center of the circle. This is the circular path. This is the center. अगर अपने को सेंटर का आइडिया है तो अपने को पता है इस डायरेक्शन में इस ऑब्जेक्ट पर क्या लग रहा होगा, सेंट्रीपिटल फोर्स, which will give us what? सेंट्रीपिटल एक्सेलरेशन. इसका मतलब अपने को मालूम चल गया कि एक एक्सिस अगर हम हॉरिजॉन्टल ले लेंगे तो हम अपने फोर्सेस से क्या डेवलप कर पाएंगे, सेंट्रीपिटल फोर्स. आपने एक एक्सिस डिसाइड कर लिया, दूसरा एक्सिस पहले एक्सिस से 90 डिग्रीज पर होता है. Can you guys see the board clearly? Yes or no? Okay. So we have decided the axis system. This will give us centripetal force. So this is one of the axes. एक एक्सिस पता है तो दूसरी हमेशा उससे कहां हुआ करती है, 90 डिग्रीज पर. Now, this is theta. You know that this is also theta. If this is theta, then this angle is also theta. Theta, theta, alternate angles. किसको रिजॉल्व करना है, टेंशन फोर्स. वेक्टर का एंगल पता है, इसका मतलब T इस डायरेक्शन में, वर्टिकल कंपोनेंट ऑफ T विल बी व्हाट, T cos theta. This is vertical component, T cos theta. जिसके साथ एंगल होता है, दैट कंपोनेंट इज व्हाट, बेस कंपोनेंट. व्हाट इज बेस? कॉस. अगर ये कॉस है, देन दिस कंपोनेंट which is pointing toward the center is what? T sin theta. T sin theta, T cos and T sin. Wrote down this much. Now one of you is saying that my voice is cracking. Does everyone find that my voice is cracking? Okay. So the person who finds that voice is cracking, just disconnect and reconnect. It's raining outside. Maybe there is some connection problem. Just wait for the connection to improve. Now, how do we handle this force system with the help of given free body diagram? Look at this. This is the cone, and if we keep V same, then you can see that this object always maintains a given horizontal plane. अगर आप स्पीड चेंज नहीं करोगे तो ये ऊपर नीचे नहीं जाएगा. It will keep on rotating in the same horizontal plane. same horizontal plane. अगर ऑब्जेक्ट ऊपर नीचे नहीं जा रहा है, अगर ये ऑब्जेक्ट ऊपर नीचे नहीं जा रहा है, then it means what? What is the vertical force acting on the object? One is t cos theta, vertically up, mg down. लेकिन हमने क्या बोला कि ये ऑब्जेक्ट ना ऊपर जाता है ना नीचे. That means what? T cos theta is balancing weight of the body. This is the first equation we got with the help of free body diagram. Write down this and then a statement. Those who are having a connection problem, just don't worry. I will send you the recording tomorrow. The statement is, for a given speed, write down the statement, for a given speed, object keeps on moving, object keeps on moving in the same horizontal plane. Object keeps on moving in the same horizontal plane, which means t cos theta is balancing weight of the object. T cos theta is balancing weight of the object. And that gives you this. Now, I'm giving you 30 seconds. Write down the second equation. This is the first equation which I have given you. Get me the second equation. Good, that's the answer. एक्सिस में रिजॉल्व करने का मतलब क्या था? एक एक्सिस ये है, एक एक्सिस ये है, एक इक्वेशन ये देगी और एक इक्वेशन ये एक्सिस देगी. ये t sin थीटा किस तरफ लग रहा है? टुवर्ड सेंटर. इसका मतलब इसका काम क्या प्रोवाइड करना है? सेंट्रीपिटल फोर्स. तो जो हमारा t sin theta है, this is going to give us necessary centripetal force mv square upon r, which is your equation number 2. T sin theta is acting towards the center and provides what? Write down the statement. Write down the equation and then the statement. T sin theta component is acting towards the center and therefore provides necessary centripetal force, and therefore provides necessary centripetal force. Now, these are the two equations we are interested in. इसके बाद सॉल्व करने का तरीका क्या है? डिपेंड्स कि आप क्या फाइंड करना चाहते हैं. If you divide equation number 2 with equation number 1, T and T cancelled. If you divide this, if you divide the whole thing, what is sine upon cos? Tan theta. M cancelled. This is V square divided by RG. Very important result for conical pendulum. Note down this. Tan theta is coming V square upon RG. Board is blurred and voice is also cracking. Again, I will ask others. The second one is also saying yes. See, 2 are saying that board is blurred, 3 are saying no. Let's use simple argument. मेरी तरफ से जो सिग्नल जा रहा है 3 लोगों को सही दिख रहा है, 2 को नहीं. That means प्रॉब्लम आपकी तरफ से है. It's a good thing. Just keep on informing me. If everybody finds that signal is blurred, quality is not good, keep on reminding me and I'll again and again ask you the same thing. Right now, since some of you are saying that quality is good, do one thing, disconnect and reconnect. Maybe signal quality will improve, or if you have an option of choosing some other network, try that. And when everyone will find that quality is not good, I will do something from my side. It's a mixed response. 4, 5 are saying no, everything is good. 4, 5 are saying yes. Logical है. जो आप yes और no के response आ रहे हैं, ये भी logical है. It's raining outside. कुछ लोगों के पास signal की problem आ रही होगी, कुछ के पास नहीं आ रही होगी. Just don't worry. As I told you, try to see as many things as you can, and then tomorrow I will give you the recording also. But stay put. We'll learn something. Again, one person is saying their screen gone blank, and I can see I use 2 different networks, and the second network I can see that everything is good. So have patience, things will improve. Now, just tell me what should we do if I need to find tension force. If somebody says that you, with the help of equation number 1 and equation number 2, find out tension force, we have been given mass, we have been given V, we have been given R, and our aim is to find tension force, then what should be done? Just tell me this. Good, that's the answer. If you square this term, and if you square this term, and then you add these, what is sine square theta plus cos square theta? 1. This way you can get rid of theta and write down like this: equation number 1 square plus equation number 2 square. Add the equations, square the equation and add them. Once you do this, you get what? Let's save time. This is t square sine square theta, t square cos square theta. So when you add, left hand side will be t square only. I'm saving few seconds. Sine square plus cos square is what? 1. Over here, you can take m common. M is common, square of that. V square upon r. V to the power 4 upon r square plus m is common, g square. So tension force T is coming m times root over V to the power 4 plus g square. This is tension force which you get using this. Put on this much. Before I go to the next part, tell me, is quality of signal good? Yes or no? First, tell me this thing. Some of you, is the signal quality good? Okay. Some of you are saying no, but many of you are saying yes. Right on the next part of this conical pendulum, find out minimum angular velocity. Find out minimum angular velocity so that a cone can be formed. Find out minimum angular velocity so that a cone can be formed. What is the question? Question is this. You can see that a cone is getting formed, but as I decrease the omega, you can see that cone almost disappears. If I increase omega, cone is present. As I decrease omega, you can see that cone almost disappears. Disappears. So what is the minimum omega which can make a conical pendulum type of thing possible? That's the question. I'll give you a hint. Your answer will be in terms of L. Why in terms of L? You can see that R is going to change. As I change omega, R is going to change. So I just want that omega for which I can say that R is greater than 0. इस तरह से चीजों को इंटरप्रेट करते हैं. कोन होने का मतलब क्या है? कोन होने का मतलब ये है, if it's a vertical thread, then R is gone. So for a cone, you must have R greater than 0. Write down this hint. For a cone to be formed, R should be greater than 0. और आप ये भी बोल सकते हैं, theta should be greater than 0. R should be greater than 0 or theta should be greater than 0. अब देखना किस तरह से आप इस चीज को डेवलप करोगे. Who will give me the relationship between L and R? What is the relationship between L, length of the rope, and R, radius of the circle? A very elementary thing. I'm asking you something which is extremely easy. What is the relationship between length of the rope and radius of the circle? In terms of theta. इधर this is L, this is theta, this is R. Now asking you what is the relationship between L and R. R upon L is what? Sine theta. This is the relationship. हालांकि अब आपके पास इतनी अकल होनी चाहिए that R can be directly written as L sine theta. What is R? Perpendicular component of L, and therefore L sine theta directly. ऐसा क्यों किया? यहां चलते हैं, ये बताएगा. Now, question is that we need to find minimum omega. This result is giving you values in terms of V. तो हमने क्या क्या करना शुरू किया वो देखना. First of all, this tan theta, इसको हमने बोला कि भाई this is sin theta upon cos theta. फिर से sin upon cos. Let's save time there. I will put values in this result only over here, and then आप अलग से करना, मैं ऐसे ही के अंदर वैल्यूज पुट कर दे रहा हूं. What is V? What is V in terms of R and omega? हर आदमी को पता है. What is V? R omega square divided by RG. क्यों किया हमने ऐसा? क्योंकि क्वेश्चन क्या पूछ रहा है? फाइंड आउट ओमेगा. R and square gone. क्या बचा भाई? This is R. Omega square divided by G. Now, over there. What is tan? Sin upon cos. What is R? L sin theta. R is L sin theta divided by G multiplied by omega square. Sin cancelled. What do you get is cos theta, or we are interested in finding omega, so let's write down omega. Omega square क्या बन गया भाई? Sin is gone. G divided by L into cos theta. A cos will be in the denominator. Cos is in the denominator. Now, I hope ये नोट कर लिया होगा आपने. Well, before I continue, I'll again ask you guys, is everything clear on the board? Just tell me fast, yes or no. Okay. So, we got omega square as G upon L cos theta. क्या find करना है? Omega, कौन सा? Which can make a cone or conical pendulum type of thing possible. जैसे जैसे आप, let's put the whole thing directly. अगर मैं इस ओमेगा को मिनिमाइज करना है मुझे, minimum, then I must increase cos. If I want to minimize omega, then I must increase cos. Simple logic. That means for omega minimum, cos theta should be maximum. and then I'll produce the logic also. अभी हमने सिंपल मैथ्स यूज की, इसको मिनिमाइज करना है, कॉस को मैक्स कर दो. What is maximum value of cos? 1. That means omega minimum is root over g divided by L. What is omega? Square root of g upon L cos theta. When cos is at its maximum, omega will be minimum. Very useful result for कॉम्पिटिटिव एग्जामिनेशंस. लोगों को लगता है कि थोड़ा सा भी रोटेट कर दिया और कोन बन जाएगा. नहीं, यू नीड टू हैव दिस मच ओमेगा, देन ओनली अ कोन टाइप ऑफ थिंग इज पॉसिबल. Put down this, put the whole thing inside the boundary and then write down result. And if you understand this much, then write down yes in the comment box. If you do not understand it because of connection problem, then just don't worry. You will get the whole thing tomorrow. अभी जो मैथ्स है इसके पीछे का मैथमेटिकल रीजन ही दूसरी तरह से देखते हैं. मैंने आपसे बोला था कि अगर कोन फॉर्म होना है देन थीटा शुड बी ग्रेटर देन 0. अगर कोन फॉर्म होना है तो फिर थीटा क्या होना चाहिए? इट शुड बी ग्रेटर देन 0. अगर थीटा 0 से ज्यादा है then cos theta should be less than 1. थीटा और cos का रिलेशन ऐसा चलता है, आप थीटा को इंक्रीज करते हो, cos डिक्रीज होता है. साइन के साथ क्या होता है? थीटा इंक्रीज होता है, साइन भी इंक्रीज होता है. व्हाट इज साइन 0? 0. व्हाट इज साइन 90? 1. थीटा इंक्रीज हुआ, साइन भी इंक्रीज हुआ. What about cos? Cos 0 is 1. What is cos 90? 0. तो cos के साथ कहानी क्या है? जैसे जैसे आप थीटा को इंक्रीज करोगे वैसे वैसे cos क्या होगा? डिक्रीज. तो the moment you are going to form the cos, the cone, your theta is almost what? 0. थीटा 0 जब चल रहा है, cos is less than 1. अब आप थीटा को इंक्रीज करने की कोशिश करोगे तो ये cos बढ़ेगा. As you increase the theta, this cos term is going to decrease, and then omega will increase. So for minimum, this. In fact, a better way of answering this type of thing is this form, that omega should be greater than root over g by L. अगर रूट g by L है तो फिर थीटा एग्जैक्टली क्या हो रहा होगा? 0. थीटा 0 का मतलब यू स्टिल सी नो कोन. इसलिए हमने क्या बोला? दिस इज द मिनिमम. तो हमारे पास जो ओमेगा होना चाहिए वो रूट g by L से क्या होना चाहिए? ज्यादा. अगेन सपोज रूट g by L, इट्स वैल्यू इज कमिंग 5 रेडियंस पर सेकेंड. तो अगर आपने 5 रेडियन पर सेकेंड दिया तो आपका कोन का एंगल क्या बना हुआ होगा? 0. You have a cone with 0 angle, which means there is no cone. The moment you make your omega 5.000000001, any number which is greater than 5, जो आपका थीटा है वो भी जीरो से क्या हो जाएगा 0.0000001 काइंड ऑफ. इसका मतलब you have developed a conical shape. This is a better presentation, but you can also remember like this. This is the minimum omega. इसके लिए cos क्या है max. Cos कब होता है max when theta is 0. Now write down banking of road. What is banking of road? नॉर्मल सिचुएशन में जब आप की बाइक और कार इट टेक्स अ सर्कुलर टर्न, then you know that what is the force which provides necessary centripetal force? Friction. If you have a horizontal road and car is going to make a circular turn, car is going to make a circular turn, then we have done these type of problems. Required centripetal force is given by what? Friction between the road and tires. लेकिन अगर आप ज्यादा स्पीड से आ रहे हो और फ्रिक्शन सफिशिएंट नहीं है, then what will happen? If friction is not sufficient, then it cannot provide necessary centripetal force, and then car is simply going to skid off the road. Something we are not interested in. अगर हमने safe turn लेना है, तो लोगों ने क्या किया? लोगों ने रोड को इस तरह से टिल्ट कर दिया. The outer edge, this is the road, the outer edge is lifted like this. अगर आप उसको ऐसे लिफ्ट करोगे तब क्या होगा? And why do we study this under conical pendulum? इन दोनों चीजों को देखना. Road. This is the road. कुछ ज्यादा ही उठा दिया अपन ने, कोई नहीं. This angle is theta. We'll see that this theta is the same theta which we saw in conical pendulum. And this is your car or bike or anything. This is the car. Now you know that in this figure the car is moving which way? Let me see if you can have, you already have this kind of visualization or not. This is the car. I've shown you road. I'll tell you what type of road this is. This is the road, this is the car. where is this car moving? Up or down? Who will tell me this? In the view which you see on the board, where exactly is the car moving? Up or down? No response. One of you is saying up, the other one says down. अब बताना. रोड ये है. This is the road. This is your car. I hope दिख रहा होगा. This is the car. This is the road. And do you see what type of view this is? This is top view. Car is moving in this direction with V. The circular turn, its radius is R, and this is the cross-sectional view of the road. What is cross-sectional view? देखना. अगर आप इस कार को just imagine a circular track, a simple stadium. You have a circular track. Now imagine with what you must have seen the stadium with a circular track where cars or bikes they race. I'm especially talking about those stadiums where you have a track which is raised about the outer edge. So, this is your bike or car. If somebody is looking from the top, स्टेडियम को आप ऊपर से देख रहे हैं, तो आपको ये कार इस तरह से टर्न करते हुए दिख रही है. That's how the car is moving. But this road and this track, अगर आप इस रोड को काट कर उसके क्रॉस सेक्शन को देखते तो ये रोड आपको ऐसा ना दिखकर ऐसा दिखता. And in this view, car is going in. It's not going up or down. It is going in or is coming out. Depends आप किस तरह से कार को चला रहे हो. But it's not going up or down. ये कार इस तरह से जा रही है अंदर. कोशिश करना विजुलाइज करने की किस तरह से मूव हो रही है कार. Let me give you an idea. देखो यार आएगा समझ में. So this is the road. I hope you can see the road now. This is the road. But it's not like this. ऐसे नहीं है रोड. हमने इसको लिफ्ट किया हुआ है आउटर एज को. Once you lift the outer edge अब आप अगर स्टेडियम के अंदर खड़े हुए हैं तो फिर आपको ये ट्रैक इस तरह से नहीं दिखाई देगा. Instead it will be like this. This angle which the road makes with horizontal is theta, and on this road your car is making a circular turn. Last attempt for this type of visualization, and then स्टेडियम जाना और खुद देखना. So this is the circular track. लेकिन ये सर्कुलर ट्रैक इस तरह से नहीं है. आई होप यू कैन सी. हमने इसकी आउटर एज को लिफ्ट किया हुआ है. लेट मी होल्ड इट परफेक्टली. शायद दिख रहा हो. Instead of keeping it horizontal like this, ये जो outer edge है ये lift हो गई है इस तरह से. Maybe feeling आ रही होगी. Not this. Everywhere outer edge is lifted up. It's not a horizontal track. It's a track like this. I guess everybody has got the visualization. First tell me fast, do you guys get the visualization, yes or no? Track किस तरह से मैंने दिखा रखा है, top view and cross sectional view. Do you understand both these views? Yes or no? Good. So in this view, this car of mass m is going inside, which is shown with the help of cross. This is V. ये जो V दिख रहा है टॉप व्यू में, क्रॉस सेक्शनल व्यू में आपको ये अंदर की तरफ दिखता. इस ट्रैक पर जब ये कार इधर जाएगी, ट्रैक लिफ्टेड है, आपसे ड्रॉ करने के लिए पूछता मैं, तो आप बोलते हैं इट्स गोइंग इन. So now how many forces are acting on the rod? Well, it's an inclined plane. If it's an inclined plane, then how many forces act on the object? Downward force mg and normal reaction force n. अगर हमारी कार इस इंक्लाइन प्लेन पर है, एक तो इंक्लाइन प्लेन इस पर क्या लगाएगा? नॉर्मल रिएक्शन. नॉर्मल रिएक्शन कहां लगता है? टुवर्ड्स. एंड कार पर क्या लग रहा होगा? एक वेट, वर्टिकल फोर्स. Under these two forces, the car is making a circular turn. Now, the moment you can visualize that the role of tension force in the conical pendulum is played by normal reaction. The moment you feel it, you will write yours in the comment box. Have this visualization along with this, and the moment आप conical pendulum के tension force को इस normal reaction से relate कर पाते हो, नहीं कर पाओगे, मैं कराऊंगा. But if you can, without my help, if you can feel that this and is going to do the same thing which tension did in conical, write yours in the comment box. Take your time. I'm giving you 30 seconds. खुद करोगे तो ज्यादा बेहतर फील करोगे. वाल अभी तक तो किसी ने नहीं किया. कोई नहीं, अपन कराते हैं. देखना भाई, This car is making a circular turn, and at every point of this circular turn, normal reaction is acting in this direction. mg is acting downwards. जो काम थोड़ी देर पहले इस टेंशन फोर्स ने किया था, देखना अब आएगा विजुअलाइजेशन अगर पहले नहीं आ पाया. दिस वॉज द कोन जो हमने थोड़ी देर पहले देखा, but this time there is no rope. Instead you have a road which is no longer horizontal. Outer has lifted up, it becomes like this. जो कार है उसको अब रोप नहीं खींच रही, यहां से क्या लग रहा है, टेंशन, नॉर्मल रिएक्शन फोर्स. व्हाट यू कैन सी कि हमारे पास एक सर्कुलर ट्रैक है एंड ऑल अराउंड आउटर एज इज लिफ्टेड अप. हर तरफ से जो भी कार मूव करेगी उस पर एक नॉर्मल रिएक्शन लगेगा, और वो कहां लग रहा होगा, towards the point of suspension. This was conical pendulum with the rope connected to the block. Remove the rope, replace the whole thing with what? Normal reaction force. I guess feeling आ गई होगी. अगर नहीं आई है, I can give you a second way of understanding this. Just take a spherical ball, keep it like this, and imagine कि इस बॉल के अंदर आपने एक छोटा सा टाइनी बीड उसको लिया और फेंक दिया. Then that bead is going to perform a circle, और जो भी नॉर्मल रिएक्शन है वो इस तरह से लग रहा होगा. This point will be the center of the spherical ball. तो हमारे पास N का रोल, T का रोल कौन प्ले करेगा? N. The moment you visualize this, अब क्या बनता है यहां पर? This is the circular track. N is acting this way. This is your cone. This angle is theta. Now how come this is theta? Theta is angle of the road with horizontal. Theta is angle of normal reaction with vertical, and they both are same. Why? इसलिए. What is theta? Angle between these two markers. Angle between these two markers. अब इन दोनों मार्कर्स के बीच का जो एंगल है, अगर मैं इस पूरी चीज को रोटेट कर दूंगा तब भी एंगल क्या रहेगा? सेम. This is one way of understanding why theta and that theta they are same. Look here. This marker, black marker, is the horizontal part. Blue marker is the road. What is black? Horizontal road. What is black? Vertical axis of the cone. What is blue marker? Road. What is blue marker now? Normal reaction. And therefore angle is what? Same. और अगर एंगल सेम है फिर कहानी पता है भाई अपने को. What was this force? mg. So this force is mg. This is n. What was the next thing which we did? We took this component towards the center, this component which was the vertical component. This is n, this is theta, this angle is also theta, which is which makes this n sine theta and cos theta component, and this one n sin theta. हमने किया हुआ है इसलिए ज्यादा उसके अंदर जाने की जरूरत नहीं, केवल हमने t को रिप्लेस कर दिया है n से, and everything else is exactly same as we did. तो इधर पहले यहाँ t लग रहा था, this was theta, t cos theta, t sin theta, everything else is same. Argument is what? N cos theta is balancing what? Weight. वहां क्या आया था? T cos. N sin is providing what? Necessary centripetal force. N sin theta is acting towards the center. Car is moving with speed v, provides this divide. What do you get? Same thing. Tan theta v square upon rg. This theta is called angle of banking. कुछ नया किया? नहीं, वही चीज, बोलने का तरीका अलग. वहां रोप थी, यहां पर रोप को हमने रिप्लेस किया हुआ है नॉर्मल रिएक्शन फोर्स के साथ. जो हमारी रोड है, इफ यू lift the outer edge by this angle theta, then normal reaction force, its vertical component is going to balance weight. Normal reaction, its horizontal component is going to provide centripetal force. And look at the cone being formed. If I rotate it like this, I hope you can see that this gives you a road which is taking a circular turn. So everywhere the car goes, normal reaction is pointing towards this. What was this? Point of suspension of rope in conical pendulum. Last 1 minute. अभी हमने जब इस रोड के कॉन्सेप्ट को डेवलप किया तो हमने फ्रिक्शन को हटा दिया है. This angle of banking concept is developed when we are assuming there is no friction between road and tires. Hypothetical situation, which is more like this, कि you have a spherical ball और इस spherical ball में अंदर की तरफ एक ऑब्जेक्ट मूव कर रहा है frictionless surface पर. In that situation you get this relation. अब जब फ्रिक्शन होगा तो वो क्या करता है, we'll see that later. क्या करेगा, हल्का सा उस पार्ट को फील कर लेते हैं जिससे कि आप रिलेट कर पाए. First write down a statement. When tan theta is v square upon rg, when tan theta is v square upon rg, there is no friction between road and tires. There is no friction between road and tires. समझना. So this is your circular track. Now tell me this. You can answer this part. It's about intuition. कितना आप फिजिक्स के अंदर घुसे हुए हैं. tan theta is v square upon rg. क्या है ये? इस पर्टिकुलर v के साथ आओगे and you can make a circular turn. So your car is over here. कार आई इस पर्टिकुलर पोजीशन पर है. This is the tan theta and you got a v. लेकिन suppose when you solve this, you got the value of v as 50 kilometers per hour. Suppose कि हमने रोड को लिफ्ट किया था, 50 किलोमीटर पर आवर से आ रहे थे आप. अगर कोई आदमी 50 की जगह 60 से आता, then tell me what will happen. This car then will go up, will skid up, or will skid down. Write down fast in the comment box. For a particular tan theta v square upon rg, if you increase the v, then the car is going to skid up or is going to skid down fast. Write down this in the comment box. Good. Car is going to skid up. फीलिंग बर्ड भी है. तेजी से आए थे, आप बाहर की तरफ निकल गए. तो अगर आप बाहर की तरफ निकल गए, क्यों निकल गए? इस रोड के लिए थीटा क्या है? फिक्स्ड. अगर मैं v को इंक्रीज करने की कोशिश करूंगा, थीटा क्या है? फिक्स. अगर v इंक्रीज होगा फिर r भी इंक्रीज होगा. ये भी इंक्रीज, ये भी इंक्रीज. रेशियो क्या बना रहेगा? कांस्टेंट. r इंक्रीज होने का मतलब क्या है? देखना. डिस्टेंस फ्रॉम माई हेड टू द डस्टर, दिस इज r. Look at this distance. This is the center. लेकिन जैसे ही स्पीड ज्यादा की, कार यहां पहुंच गई. Look, this distance has increased. What is this distance? r. यहां से v था, v को इंक्रीज किया, कार यहां पहुंच गई. क्यों? So that it can also increase what? r. लेकिन अगर हमारे पास रोड बहुत ज्यादा नहीं है, तो फिर तो आप बाहर लैंड. We don't want that to happen, and therefore what happens? As the car gets a tendency to move up, टायर्स और रोड के बीच का जो फ्रिक्शन होगा, that will also develop. कार अगर ऊपर जाना चाहेगी तो फ्रिक्शन कहां लगेगा? नीचे. And similarly, if a car is moving with v which was 50 kilometers per hour, अगर कोई 50 की जगह पर 20 से आता, had it been a frictionless surface, तो ये कार नीचे आ जाती. लेकिन अगर फ्रिक्शन है, it has a tendency to come down, then friction will act up so that ये जो shifting है, it can be blocked, it can be opposed. How do we do that? We'll see that later. Hopefully यहां तक की कहानी क्लियर हुई होगी. There was some connection problem and all. Don't worry, I'll send you the recording tomorrow. Note down everything and then you can leave. Thank you very much.